these are some questions. So the first week, I think people generally did pretty well in the mini quiz. So there is feedback on there. So if you do select the wrong answer, you should get feedback about it. But I thought it'd be helpful to talk through these. So just 2 questions from last week because it wasn't clear that everyone was understanding what was going on. So where is the best place to document confirmed details about a story? So we've got 4 options here. So what I'm going to do is talk about the options and a little bit about exam technique as well. So we've got in acceptance tests, in a conversation, in a requirements document, or on the front of a story card. So I guess the first thing to think about is, from an exam technique perspective, is what is the question actually asking us? And it's asking us about the best place to document confirmed details about a story. Because I would say probably a conversation is not where you document anything, so we can probably rule that out, right? So that's fair enough. And indeed, no one put that, I'm pretty sure they didn't. You could have them in a requirements document. This is an option. You could have them on the front of a story card. This is an option too. So these are both things that, you know, it's possible, right? So it's not beyond the realms of possibility that we might document confirmed details about a story in one of these things. In Agile, we tend not to have kind of requirements documents in there, or specifications in their traditional sense, but you could put stuff on we could put notes on a story card, certainly. But actually, what you really want to do in this situation, if they're confirmed, is they become confirmed when you pin them down with the customer in the form of acceptance tests. So this is your kind of contract that you have with a customer, where if you're able to agree the acceptance tests, and an example of this is the kind of data that we give you in your user stories for each week. So we'll give you kind of examples of input and expected output, and these are kind of acceptance tests. So it's like, if your software is able to meet these requirements as we've specified them here, then we're going to be happy with it. And in fact, there are tools that you can use, that you can use if you're not a programmer. So customers can do things like work on a spreadsheet where they will input certain values and what the expected outputs are and so on. So this is a kind of established technique that we can use in Agile software engineering for kind of maintaining this. So we want them in acceptance tests. So that's the correct answer there. And then just looking at one more question. Which of the following best describes an epic? So we talked about this last week. So we know that it's not a longer than normal sprint, because sprints are time boxed. So the whole point of a sprint is that it's time boxed, and we don't want to kind of vary the length of our sprints, generally speaking, because that kind of can certainly in Scrum upset the rhythm of the team. So you can change sprint length, but you tend not to do it arbitrarily. So you wouldn't just say, okay, we're going to sprint for longer than normal, because that might not be sustainable. It's not a description of all the functionality, design of the product. What's that? What's the description of functionality? Yeah, so that's the product backlog. And if we look at the last two, we've got a large user story and a collection of related user stories. So it is indeed a large user story. The collection of related user stories, obviously we discussed this, as in an epic might actually end up being a collection of related user stories. But for the purpose of the backlog, it's a large user story, right? So it's one that you're probably not going to try to tackle by itself, but it's still an encapsulated item of functionality, which we might want to break down later on. So again, this is slightly nuanced. So although it may end up that it becomes broken down into other user stories, when you describe it as an epic, it is a single user story, and you're using that as a technique for kind of still describing a particular piece of functionality. Right, so I shall hand over to you, Rob.
Excuse me.
Yes?
What's the difference between epic and a spike?
Right, so a spike is where you put in a story because you have a lack of technical knowledge. You're using a new technology and you think, I'm going to have to put some time in to learn about that. So you put in what we call a spike, which is the period of time you're going to spend learning about the new technology. Yeah.
So it's included in the same story, like it's part of the story?
A spike would be, so you could a spike could implicitly be included in an epic, that's right, in terms of you might, but you wouldn't describe it as such, so it would only become spike when you actually put it into the sprint, in a sprint planning phase.
Excuse me.
Yeah.
You told us that the user story consists of COMP, compensation and confirmation.
Yeah.
3 things. And this is the story. Which one is which?
So, in terms of the story, okay. The card conversation confirmation is sort of an abstraction. So here, the card is the piece of paper, or the part of the screen that we're looking at. Conversation is obviously when you come and have a chat in terms of confirming the details.
It's not recorded here.
No. So the conversation, the card is a reminder. I think it says this in the slides actually. I'll have to check that.
Yeah.
It's a reminder to have a conversation.
Yeah.
And then the confirmation obviously is these.
And this is what we call acceptance test.
That's right. Yeah. Does that make sense?
Yeah.
Okay. Good. Right.
Okay, thank you. So, I'm going to go through a couple of sets of slides this morning. The first one is going to take you through some of the questions that we might have about how Scrum might work in the real world when we've got a situation that is slightly more complex, shall we say, than you have in the lab with 3 or 4 people working together. Okay, so we can take beyond simple Scrum. That will happen fairly regularly in the real world, and this can be caused by one of 2 most likely scenarios, which is that you've got larger products than we're dealing with in the lab, or distributed teams. These are 2 quite common scenarios. What are we talking about when we talk about larger projects? Well, for instance, how many developers, I don't know the answer to these questions by the way, but how many developers work on things like Office or Google Docs or Oracle Database and large numbers, thousands, I would imagine, for all of those products. Can we use Agile for this size of project? And say with a distributed team, can we use Agile for non-co-located teams? So those are the sorts of things we'll be talking about today. Okay, so let's talk about scaling Scrum. So we've got a big project. What parts of Scrum might facilitate scaling? That's something we might want to think about. There are various bits we have of Scrum. We have things like we have the daily stand-ups. We have iterations and that sort of thing. Where might we scale Scrum? If you recall from the BBC last week, they mentioned that there are multiple teams working within even within small sections, like they were in the syndication team, weren't they, last week? So they have multiple teams in there, and the BBC also have multiple teams working on other products like iPlayer. So multiple development teams is one way to scale Scrum. We can also scale a product owner, and I'm going to go through some of these scenarios, and that might be hierarchical. So for example, if we're thinking about something like Microsoft Office, you might have a product owner for the whole of Office, and there might be a product owner for Word and Excel and PowerPoint and all the other bits and pieces that go into Microsoft Office might have their own product owners, but you might have a top level Office product owner as well. Another thing you could do is you could share the product backlog out. So you've got this idea that there's this backlog is a set of things that need to be done. You could have different teams working from the same backlog that's going to ultimately feed into the same product. And we also need to then coordinate work amongst teams somehow if we're going to do that. So if we're scaling Scrum, we need to think about how we manage dependencies, and we might have to think about how we coordinate sprints. So these are all things we're going to have a look at. So what does scaling the product owner look like? Well, I've just mentioned that you might have in something like Office, you might have multiple people looking after different parts of it. This is an example from Agile game development with Scrum. And he's suggesting there that this is one way you might do it. You might have a product owner that looks after the driving physics and the driving AI team. That might seem fairly sensible to have a single product owner for 2 driving teams. You might have a product owner for the online team. Again, that seems sensible because it's quite a different part of the product, and you might have a product owner for the user interface team, and it might just happen that the lead product owner actually takes a more detailed view of one of those teams while also being the point of contact for the other two. So that's the sort of thing you can do, and it really just depends on what your team, what your product looks like, and how your teams are set up. That how you might do that. So why is it important to scale the product owner, and what is it about the product owner that it's important to have scaling if you've got too many teams? Go and have a think about. They'll give you an idea about what if we didn't have multiple product owners, what's likely to happen.
Is the product owner the one who is the interface with the other world to make sure that we operate correctly and nobody interfere with our world?
Yeah. So
they did this.
Well, the product owner, yes. So the product owner is the sort of the interface between the teams and the business in terms of what the product's going to be doing. And so the thing is, I think you sort of getting to the point there, is that that's quite an intense situation to be in with a large product. You're going to have lots of conflicting or potentially conflicting on your conflicts on your time, and also where we've got something like this, for example, another thing would be specialist expertise. So that's I would say that diagram is more looking at sort of making sure the right expertise of a product owner is in the right place. But certainly, if one was being the product owner for example, Microsoft Office, you could imagine that it would be a bit too much to have to look after all the different products on your own. Okay, so I mentioned sharing the product backlog as something that you can do as well. And note that in this sort of thing, if we're going to carry on with the game analogy, then we're thinking that the product is the whole game and not the individual pieces. So when we sort of think about the product backlog, we have one product backlog for a product. So that game might have 4 teams working on it, but they will have one product backlog between them. And really, you need to to globally prioritise the items in the backlog. So it's no good, I suppose, to carry on with the diagram we had before. It's no good having a completely amazing online experience for a driving game and have no driving AI or driving physics in there. One still needs to prioritise things globally. But if you've got one backlog for a large and complex product with many different facets, how do we actually keep it to a manageable size? Well, there's 2 sort of ways of dividing things up, and to be honest with you, they come out to be pretty similar, but one's called views and one's called themes, and we'll show a couple of examples here. So in this one we've got here, we've got a product backlog for something which it seems that there's some payroll involved and some human resources involved there. And so this is actually the single product backlog in the middle, and the payroll team has a view of it which just sees relevant items for them, and the human resources team has a view where they only see relevant ones to them. And I suppose there's a couple of interesting ones there where they can both see the same item in the backlog, and presumably at that point they'd probably have to coordinate which team was going to work on those items, so they didn't somehow both end up implementing it twice. So that's the sort of idea about views. Single backlog, but different teams can see different items in the backlog. Themes, again, looks very similar in practice really to the teams, but you're sort of splitting the backlog into into themes more in sort of more logically into groups, I think, in that sense. And so you've got your chief product owner will control what goes into each theme, and then the product owners of the various teams will. This is an office example again. So product owner for the word processor team will be able to see these themes. We don't know what these themes are, but whatever these two themes are must be both relevant for the word processor application. Okay, so again, in practice, what's the difference between views and themes? I'm not particularly sure. Really, it's just a way of making sure that the product backlog isn't an overwhelming sort of presence for any one particular team. Okay. So, when you're doing all this sort of stuff, then obviously it's important to start managing dependencies, because you've got lots of different teams working on different things, and what we don't want to happen is that a dependency of one team or another actually blocks work in a different team. So we don't want someone on team A, for example, blocked waiting for team B to complete a feature. And this is something which is fairly, it needs some thinking to sort of make sure you get this right. One thing we might do is something like look ahead sprint planning. So we've talked about you do a sprint plan at the beginning of every sprint. Well, what you might do is you might do that in your individual teams, but what you also might do is you might have the product owners and maybe a couple of senior technical people from each team get together and do some slightly further planning of how they're going to divide the work up, just to make sure that these things happen. So you might actually start to think a couple of sprints ahead about what sorts of things might happen. Not in any particular detail, but just the question of, if we don't do this work in this sprint, is that going to stop someone doing some other work in the next sprint, and that sort of thing. Okay. So examples of things that might actually cause problems are, in terms of the dependencies, is not catching sorts of interfaces which might be required, and actually also the interfaces which you don't know you're going to have initially, unintended interfaces, shall we say, and then they suddenly appear somewhere in the process. The other thing one can do is one can share team members. So you could have someone, if you go back to that game example where you've got people doing driving physics and driving AI, maybe the driving physics and driving AI teams have a couple of people who actually sort of logically sit in both teams. Maybe they swap every couple of sprints, or maybe they are actually involved in both teams somehow. That sort of thing can help to manage dependencies as well. Another thing that you might do is you might have an extra team whose job is to take work from the various other teams and integrate them together, and their backlog will be, or the backlog bits of the backlog they see, their sort of sprint planning will all be about taking the various bits that other teams have put together and actually fitting them into the product and as a whole, and making sure it all works. And of course they then will actually have quite a good view on where the dependencies are.
So what's the difference between the last 2 points? Seems similar. Shared team members or user integration team?
So I think basically you're right. I think basically the end result is similar, but I think it's just a slightly different way of doing it. So an integration team would be a completely separate team who takes bits of product from the other teams and just ensures it works together. Maybe they'll be the people starting to write integration tests, and they'll sort of build larger and larger and larger versions of the product. Whereas with sharing team members, I think it's more about at the sort of day-to-day level of making sure that things are happening in the right order. I think the end result, hopefully, is a working product in both cases. It's just slightly, I think sharing team members probably thinks about dependencies sort of a bit earlier and a bit more in the loop, and having an integration team, you might still have issues where you say, this interface just hasn't been implemented quite right for these things, so there's going to be a bit of an issue. But I think sharing team members will catch things earlier. But hopefully they pretty much do the same job. Something else we mentioned was coordinating sprints. And there's a couple of ways you might coordinate sprints to help with dependencies. You could stagger them. So if we're looking at the game idea again, you might just have it so that the teams are just slightly staggered with their sprints, and that should mean that anything that the driving team needs in its second sprint there, I mean, something that's been completed by the multiplayer team in their previous sprint, then it'll be available, and that sort of thing. This actually helps the product owners, because of course the product owners are very important at the start and end of a sprint, especially because they're involved in sprint planning and in sprint review. So especially if you're sharing product owners, but even if you're not, staggering the sprints helps the product owners. They're not sort of all massively contended at the start of a block of sprints. It also means you could share Scrum Masters, again because of the contention that especially happens at the start and end of sprints with things like planning and reviewing. But as I'm sure you can imagine, dependency planning is actually made slightly more difficult here, because we're not having a situation where we've got large coordination points through the teams. We're having to sort of what happens if the multiplayer team in this second sprint suddenly realise they need something from the shooting team. The shooting team are already in their iteration, and so they'd have to wait quite a long time to get that. So and with the planning is difficult, because the shooting team is planning after the driving team and the multiplayer team have already started. So there's a potential here that you get a sort of a one sprint lag on various things that need to be done coming through, which might be okay, but again, as with all these things, it requires some foresight. Then, of course, the obvious opposite to that is by synchronizing sprints, and that makes planning the entire operation a lot easier. You've got an integrated view of the whole product, right? At various well-defined points. It also means that teams can exchange members, because we talked about sharing team members and that sort of thing. That would be difficult to do in the staggered sprints situation, because to be able to do that, you would have to have people sort of leaving a team in the middle of a sprint, which is something we generally don't do. Certainly wouldn't want to plan to do it, really. But in this situation, we have good solid start and end points, and as we've discussed, what we're hoping for is that everything is kind of in a good state at these points. So that's a good point to exchange team members. And this, as discussed with the last slide, this is something that this works well with multiple product owners, because they can all be in their teams for planning, and they can do some coordination amongst themselves around that.
Is it possible to be implemented in the real life?
I'm sorry, say again?
Is it possible to be implemented in the real life, synchronized sprints, 100%?
Is it possible to do this like this? I think it just depends on I think scaling any of this stuff is quite tricky, and however you do it, it requires experience. But I think I suspect that this method of actually coming together, the project coming together at hard points where everyone's at a point where things are in clean state, hopefully, probably is the one that's most common. just in the sense that you could have in your sprint review sessions, you could do one within your team and then do a whole project one as well, and get everyone together. So I think in reality this is probably the most common. So if you have if you are, however you're splitting things up, obviously we've talked about having your scrum meetings, which is your daily stand-ups and so on, but I mean it still would be useful in some cases, I'm sure, to be able to coordinate within the sprint between other teams. So we might have this idea of having a scrum of scrums, which might look something like this, where, and obviously this is a very big agile project with many teams. So we've got this is a sort of extreme example where we've got sort of we've got 3 levels here. So we've got, say, a product team here, which is actually split into 9 agile teams, and you might take one each from these stand-ups to then go and have a stand-up amongst the whole product, and then you might take one each from those to have a whole stand-up for the entire thing. Now, whether or not this is how this would work in practice, I don't know. I've never worked on anything like this size, but this is something that Mike Cohen, who's one of the agile, the original agile people, has suggested might be one way of looking at it. Yeah, I'm not sure. So an interesting question here would be, so each of these teams, we've got 9 in each product, should we say, and each of these teams has developers, UI people, a scrum master and a product owner, let's say, or maybe the product owner's sort of looks after these sort of things. But who would be a sensible person at this level, should we say, to go up and take part in our first scrum of scrums? Or who would not be a good idea?
Product owner.
Sorry?
Product owner.
Are you suggesting the product owner is not a good idea?
No, he's the interface with the stakeholders.
Right, so you probably wouldn't do the product owner. Well, so let's say that there's not a product owner for each of these teams. There's a product owner for the product. Then it wouldn't be probably wouldn't be a product owner that goes into there, because then it'd be one of them. Product owner might be in there, but the product owner possibly wouldn't be in all of these. So you might have the product owner in this one, and the product owner might go to the top level one, but still the risk of that, because a scrum of scrums is about, or a scrum is about sort of, you're in the sprint, you're iterating, you're trying to sort of, at that point hopefully most of the issues are technical, then you might not use a product owner for that reason. Same for the scrum master. Because as much as anything you might find the scrum masters are shared, same as the product owner, and therefore probably not someone who'd go into the scrum of scrum. So I would say largely you'd probably have technical people bubbling up. Product owners might be in the top one, so long as they're in this one. But I wouldn't expect to have product owners in each of these, especially because they'd be shared anyway.
So who's responsible for the communication between the two parties?
Sorry, which one?
Who's responsible?
Who's responsible for the communication between the levels?
Yeah.
Oh, well, in terms of overall responsibility for the products and the project will come down to the product owners in terms of making sure the communications happen. But we're dealing with good technical, hopefully good technical self-organising teams here. So anyone from a team should be able to be part of those conversations. So we talk about self-organising teams, keeping quality high, everyone taking ownership of everything. Anyone, certainly any technical person, should be able to go all the way up to the top and it might be that you'd rotate that round. Okay, so that's sort of taking that's taking something which is taking Scrum to a large sort of product using scaling. Let's have a look now about distribution, because something that you'll probably be something that's kind of obvious these days is that teams are distributed all over the world. Google have offices in Mountain View, that's where they're based, but also they have a couple of places a few places in the UK and all over the world. So and the products are developed across different locations. So there's different ways of distributing work between distributing teams. One thing is that you might make sure that certain parts of a product are only developed in one particular location. So let's take Microsoft Office as a good example. So the product will be owned and fully integrated probably at their head office, let's say in Seattle. You might have the Word team in London, you might have the spreadsheet team in Seattle, and you might have the PowerPoint team in Silicon Valley or something like that. But the idea there is maybe that the sort of large blocks of the product, as in Word itself, is all being done in co-located teams, but you've managed to distribute a larger set of products like that. Or you might actually just say, no, it'd be much better actually if we distribute the people working on Word across the world, and the same with PowerPoint, and the same with Excel, that sort of thing. And so you don't have anything which is developed in just one place. This might have advantages for things like localization of a product, though. So the best place to localize something for right to left text, for example, might be in a country where people use right to left text. So that might be a strategic reason to do that. But we'll talk about different ways of doing it now. So, problems. Naturally, physical separation is one. So, one of the nice things about being co-located with people is you can just go and ask them a question about something. You meet at the water cooler or at lunch and that sort of thing, and lots of collaboration can happen very easily. But if you are physically separated, then any communications, even you can't gather around the whiteboard so easily, even with good technology. You're going to be sort of using chat or Skype or email or old-fashioned phone calls to actually work together with people. Physical separation is one thing. Time zone differences is another. There's a sort of nice illustration on XKCD about how time zones, you don't have to go far before time zones start to get really difficult to work with. So for example, so I've been this week actually I've been in Denver up until yesterday in the United States, which is 7 hours out, and so I was getting up if I go up at 7 o'clock in the morning, people here were already at 2 o'clock in the afternoon, and it's quite difficult to coordinate work, and it's even worse if you're in, say, here and you're collaborating with people in California, because they are 8 hours they're 8 hours behind, and so your work day almost doesn't overlap without some planning, either without them coming in early and you staying in late or that sort of thing. And going the other way is even more difficult. So sort of Japan is. So I've worked on projects before where we've had people in the UK and both coasts of the United States and Japan and Australia all in trying to get a time for one phone call, and someone somewhere has to do it at an entirely inhumane time. You just got to hope that you're in the section with most people, so you get to maybe have the biggest influence on what time it is. And there's also cultural differences. The cultural differences can need to be thought about sometimes when you're dealing with different teams. There are some very different working practices around the world, and if you're distributed in those sorts of ways, then they need to be taken account of. And they don't even need to be in what you would consider to be very different places. The working culture between the UK and the US is actually it's largely the same, but there are some differences, and so that sort of thing all has to be taken into account.
They don't go on holiday in the US.
So?
They don't go on holiday in the US.
No, that's the thing. Yes, one of the things is they have like 2 weeks of holiday a year.
And they don't use most.
Yeah, and that sort of thing, and they don't get things like maternity leave or paternity leave. I think. So this is sort of a kind of nice Dilbert I quite like. They're talking about outsourcing some of their programming work. They say we're going to send it to Elbonia. This is a made-up country, by the way, right, in Dilbert, if you don't know Dilbert, to take advantage of the time difference. So the thinking here, right, is that, well, while people in the UK are asleep, there are other parts of the world awake. Why don't we get them to do a load of work, and then when we come in the morning, we'll pick up the baton, and so I mean, my boss at the moment, he's worked in an agile situation where they actually had three distributions around the world, so that apparently the work never stopped. Each group did 3 sets, one set of 8 hours, and in the right place around the world. And the thinking is that you get to the end of the day, you're using things like TDD, you're using methods which mean that you leave work with everything in a clean state, and someone else picks it up and runs with it, and so the development never stops. So this is what they're thinking about here. They say we just give our requirements to the programmers at the end of the day, and in the morning we just get loads of good stuff. And of course there's not much communication, so they're saying, yet again, I have no idea what they want, and they say, well, let's just pretend we died. I mean, it's probably not quite that desperate, but I think sort of trying to do the sun never sets on development. I think that requires some very careful planning and very careful distribution. And of course, there's going to have to be some overlap somewhere, because you are going to have to at least pass on something like, we had some problems with this today, but we think we've figured it out. There's going to have to be some communication, and if you're doing it in 3 blocks of 8 hours, then technically there's no overlap there. So anyway, it's not something I can imagine being particularly pleasant to work with, but people try it. And if they're desperate and they're time constrained, they do try it. Okay, so that's all I was going to say about distributing and scaling Scrum. I'm quickly going to start the next section on technical practices, and then we'll take a break and I'll finish it off depending on how far I get through. Various things like maintaining quality and refactoring and that sort of thing. I'm going to quickly go through some of these bits in terms of how one might want to do these sorts of things and why they're important, really, is the main thing. So, start off by talking about quality. So quality is really important for agile teams. I've mentioned it a few times in passing, and it's important because we need to be able to hand work over to other people, and really quality must be maintained as a whole team responsibility. Everyone in your agile team must be trying to produce the highest quality work they possibly can at all times, so that someone else can take what they've done and work with it in the next sprint, for example. Really, to maintain quality, you must integrate testing into the process, and quite naturally for this course, which has TDD in its title, we're going to suggest that TDD is a great way to do that. Well, it really is, because you make sure that all the tests are there. And so one level of quality you might look at is, do the test pass? That has a certain, gets quality to a certain point. It's not everything, of course. Well-written code can still be passing. So badly written code can still pass tests. But TDD is certainly a good way to make sure that quality is maintained. And then we must automate testing as much as possible. And there's this stuff called continuous integration, which I'm going to talk about in a minute, usually known as CI, because continuous integration, certainly difficult to say when you're jet lagged. And we must also maintain good engineering practices. So it's not just about making sure that the code passes its tests, that it's also that it's well engineered, clean code, sort of simple if possible as well. And this means that we need to, within our technical teams, we need to actually collectively own the code. So this isn't, for example, an example of a counter-example of collectively owning the code is that, for example, on a team, I would write all the database queries and all the code which interfaces with the database, and for example, Caroline could write all the code to draw the UI and that sort of thing. So that wouldn't be collective ownership, because I would know everything about the databases stuff and Caroline wouldn't know anything about it, and vice versa. I wouldn't know anything about the UI and Caroline would know all about it, and that would mean that we would end up being sort of siloed within our own teams, and if I was off sick, then no one else would have a good enough, possibly wouldn't have a good enough understanding of how to deal with the database code, and development might stall. So collective ownership of the code. People should be pulling tasks off the backlog in such a way that they're keeping, they can see the whole code. They're working on different types of tasks throughout the sprint. So I would take some database tasks and some UI tasks, and Caroline vice versa. And this means that we all sort of know how all the code works, so we can all work on any part of the code. So, and it also means that we all need to look after the quality of all of the code. And the other thing about quality is paying off what's known as technical debt, and technical debt is something I'm going to define in a bit. Right. So we mustn't leave testing to the end. We've said this already a load of times. Don't leave testing to the end, because it doesn't get done largely, but also because it's harder to test if we leave it right to the end, let alone whether we have the time to do it. So, because for example, how do you, if you don't do testing till right to the end, I mean, how do you improve the quality of something that is already finished? You know, it's a lot more difficult, a lot more time consuming, a lot more expensive to keep them to go back and improve the quality of something which is already finished. So this is why we test as we go through and keep an eye on this sort of thing, so that we can make sure that the quality is high all the way through, and once we're finished, the quality is just high as a result of it being kept high. If we leave testing till the end, then we don't really know where we are. I mentioned this a couple of times last week in the TDD lecture, where I was saying that if you have a load of tests and they're all passing, and you know which bits of the backlog you've done, then you can be sure that those bits of the backlog really are done, because the tests are saying that the code is finished. So testing in that sense sort of becomes like either a progress meter or a probe. You know, we run the tests. the tests are failing somewhere. Well, we know we've not finished, so that's great. It's good to know. And we can then see which tasks haven't been done because we're sure that all the other tasks have tests. So if we have a failing test, then hopefully it's just in one place, and we can then get that fixed. Then the tests pass, and we know that all the tasks on the backlog have been finished. If again, this is all a feedback thing, so we don't get feedback if we don't have tests. If we leave testing to the end, so if we haven't done any tests in an entire sprint, and we're showing the software to the customers or the product owners at the end of our sprint, and they sort of look at it and they say, "Oh, this looks really good. Is it finished?" And in some ways, if we haven't got any tests, the answer is just we don't know, because what we've shown you works, right? What we've shown you works, and that's because we know where the problems might be, so we just show the bits where we're pretty convinced it's worked. But if we had all those tests, if we had 100% coverage of the code, or nearly 100% coverage of the code, then if we show something to the product owner or a customer, and they say, "This looks great, is it done?" then we can actually have a definitive answer: yes, it is done, it's fully tested, and what we've shown you isn't just this sort of like nice path through the software that we know is safe. We've talked loads about how if we leave testing to the end, it gets cut, and so this is why we say we should test all the way through with TDD. So I'll just, before we have a quick break, I'll just talk about continuous integration to finish this section off. So continuous integration is the automation of ensuring that quality is high, amongst many things. So it's a regular build process which is triggered on check-in. So you're coding away, you've set up a couple of commits into the repository, and when you push it to the central repository, continuous integration kicks in. And continuous integration basically is the process of running all of the tests on all of the code separately, away from your machine, effectively. I suppose it can be running on your machine, but generally it's not on your machine. So you're developing, coding, you push something up to the repository, that triggers a continuous integration server to pull the code, run all the tests, everything it can run. It can run all the Ruby, all the unit tests. It can run all the integration tests. Anything which can be automated, continuous integration will run, and not just on the bits and pieces that you've just been working on. It will do a whole regression of the entire code base, and it will then send a report back. So if hopefully you've not pushed any code that you've not tested locally, but continuous integration will check things that you haven't been working on locally, that they still work, and it'll email you to tell you if it doesn't work. So this just doesn't work without tests. The whole premise of being able to do continuous integration is that your code is tested, well tested, good coverage. And so test-driven development is a great way to make sure that you can take advantage of things like continuous integration. And the nice thing about continuous integration is that it can take, because it's being done separately, out with development. We talked last week at TDD about having to have really fast feedback, and so the bits of code that you're working on, when you run the tests, you want to get that feedback straight away, so that you're just running the tests that you need to run to get that. Continuous integration is working is a separate process. It's just happening in the background while you're carrying on with the next task, so it can take a bit longer. And so we usually do things with continuous integration like we actually run on multiple different scenarios as well. So rather than just running all the tests on, say, one version of the operating system, you might actually run integration tests across other operating systems. So say you're developing your code locally on a Mac, you push it up to the source code repository. Continuous integration will both check it on the Mac and, say, Linux and Windows as well, just to make sure you've not broke it. That's the sort of thing you would set up. You wouldn't necessarily do all that all that stuff automatically on your own machine. Just let the continuous integration server do it. Equally, other things like different versions of, say, underlying languages. So, say you're programming in Python, as you are. You might be using Python 2 on your local machine, and the continuous integration server could check various different versions of Python 2. So just in case, let's check it's working on 2.5, 2.6, 2.7. You would only use one of them on your machine, but let's just make sure that we can be flexible with versions, and so the CI server would do that as well. Likewise, any other things that you might rely on. So I'm going to break there because we've been going long enough. It's time for a break. Are there any questions on this so far? Okay, I will pick up here, and we'll talk about other good engineering practices, and then Caroline will talk about estimation. We'll come back at 10 past 11. Right. Okay. So we got to here. So we've just talked about continuous integration. I'm going to now carry on and talk about good engineering practices we might follow. So most of these things we've kind of talked about already. Pair programming and code review is something that a lot of agile teams do. I think it was obvious from the BBC last week. They do pair programming. One of the things they did in their demo of TDD was that one of them wrote a test, the other one then wrote the code to pass the test, then wrote the next test, then the other one went back, and you could see how that was working. So it wasn't that one of them was always writing tests and one of them was always writing implementation code. They swapped it around like that. So that's a good way to keep quality high, because you've got two people always looking at the code, and to make sure that bugs are caught early and that sort of thing. So paired programming alongside testing is very powerful. Also, code review alongside testing is very powerful. So pair programming is kind of like code review at the same time as working. So you've always got one person reviewing the code as one person's writing it. Code review as a separate exercise is when, say, someone's been working on some code on their own and they push it up to the repository, and before it's actually accepted, someone else will just cast their eyes over it, make sure you're using the right sort of coding styles, and that maybe you've named variables in such a way that is consistent with other people, and that the code generally does what you might expect it to do given the task at hand. So you wouldn't normally do pair programming and code review, because pair programming sort of combines the two processes in one go. Another good engineering practice that one should follow is to refactor often. Refactor, as and when needed, and remember that it changes structure, not behaviour. So you're changing the how, but not the what. And when you are refactoring, you're not writing tests when you're refactoring. Pure refactor is just about making the code that is already well tested and is covered by tests work in a different way. Another good thing that our good teams will tend to do is to not increase the entropy or disorder of the code. So this is kind of like just making sure that the code is always as clean as possible when you finish something. There's a the Boy Scout rule by Robert Martin is that you leave the campsite cleaner than you found it, that sort of thing. So as you're going through the code and doing some adding some new functionality to it, make sure that before you sort of sign it all off and finish it, that you've actually refactored it so that it's as simple as it can be, and clean code and that sort of thing. Don't just say, oh well, I've kind of finished this and it's a bit quick and dirty, so I'll just pass it on. That basically means that someone else coming in has to maybe spend more effort than necessary to work out what you've done if you don't do that. Another example, actually, of being careful with the code is that there's quite an interesting analogy in the real world where if a place is run down and has been vandalised, it's more common that people will vandalise it further. So if there's already a bit of graffiti on the wall, then it's much more common that more graffiti will join it. And so the vandalism begets vandalism. So I think the analogy with the code is if a couple of people are not careful with the code, then maybe the whole team starts to get a bit careless with it as well. Because after all, why should other members of the team put up with and fix the vandalism of others, shall we say? So this is all basically to talk around collective ownership. We mentioned this is an important thing, and really the developers of a team should all feel ownership of the entire code base. So I couldn't say things like, well, that's Caroline's code, I can't touch it, because well, that's just not the way one would run a team like this. It's much more of a sort of a more collegiate atmosphere where I said, well, I'm doing this task, and yes, Caroline's written a certain amount of code for it so far, but it's well written, it's clean, I can see what's going on. I will happily add to it, and so on. This is good because it ensures that no developer becomes over specialised, something I mentioned quickly before the break, and it makes sure that we don't have only one person who understands little bits of or even large bits of our code. So so we're trying to make sure that the project has a high bus factor. Now, has anyone heard of bus factor before? Yeah, a couple of nods. Well, basically, for those who've not heard it before, bus factor is a number as how many developers would need to get hit by a bus for your project to fail. Right? So we used to use Oxford Road just outside as an example of this, but since they took all the traffic off it, apart from buses, it's a bit safer. But so basically, what you're saying is if a particular
somebody has been hit by a bus,
right.
She's okay.
Okay, good. Right. Anyway, so basically, if someone, so if for example, Caroline was the only person on the project who knew anything about the UI code, and she got hit by a bus. That's an analogy, by the way. So hit by a bus could also be just taken seriously ill, or get another job and leave the team. It's basically someone's now not available. So if Caroline was the only person who knew about the UI code, and then Google came along and offered her 3 times the amount of money that we could offer her, and she left, we'd have a serious hiatus in the project where we got other people up to speed on that part of the code base. So within your teams in the lab, try and sort of think about, is someone maybe doing a bit more of the work on, say, the underlying database, or is someone doing a bit too much work on the user interface, and try and switch it about a bit to try and keep that bus factor as high as possible. So people have objections about collective ownership of code, so let's go through some of those and discuss them. So it's my code, I won't fix other people's bugs. Okay, well this is an objection someone might have against collective ownership of code. Well, this works both ways, right? So if you fix other people's bugs, and let's be clear here, we're talking about agile teams who are full of good people who are testing code and trying to are generally good and trying to do as best they can. They're not putting bugs in there on purpose, right? So these things do happen. Bugs do happen. But if you fix someone else's bugs when you come to have to do the work with that bit of code, then it means that you've not sort of disrupted the sprint and sort of having to drag someone over to do that for you. And also other people will fix yours, right? You'll be writing bugs as well. I mean, everyone writes bugs, and you don't intend to, but they happen. So, and also the idea here is that sharing the code is going to mean that everyone's a bit more careful with it. And sometimes bugs only really come to light when you've got a second pair of eyes on them. So just having this collective ownership of the code means that bugs will surface, and so taking care of them as soon as you can is definitely the way forward. Okay, I don't want anyone judging me by my code. So this is another objection people have to collective ownership of the code. And this is quite natural, you know, one doesn't like to be sort of like judged on, and particularly I think developers can be sensitive about this sort of thing. But really, the thing here is that judging sounds a bit, you know, pejorative and a bit negative, but actually it can be positive. You know, don't forget, you might write something like really neat and write a really neat and clean implementation, and someone will say, "Wow, I saw that sort of thing and it was really good." So, and even when it is a bit sort of like, "Oh, well, could you not have done it?" something like that. I mean, it should be done in the right way. You know, you should be collaborative. Remember that other people are going to be looking at your code, so don't just, you know, be nasty about other people's code. It's a learning process. You know, use it as a learning process. It's faster if each person owns part of the system, possibly in isolated incidents. But we have to remember that the bus factor rule. It's worth putting a bit of effort and costing yourself maybe a bit of time with people working on different bits of the code together, so that we're keeping the bus factor high, and you know, so it may be faster, but is it actually faster in the long run if something was to happen? And also the other thing to remember is that, well, this thing about ownership, we talk about collective ownership, really the real owner of any code is the company you're working for, not you. So might as well be fairly liberal with what you mean by owning it. Right, technical debt. I mentioned that earlier. Technical debt is this sort of idea that you know, there are issues in the code, and basically technical debt is the cost of working on a system that's poorly designed, or is poorly written, and or has unexpected behaviour that must be worked around, has missing pieces but claims to be finished, uses outdated external libraries, or is indeed deficient in any way. So basically what we're saying here is all of these things are some amount of debt, and the debt analogy comes from things like mortgages and that sort of thing, in the sense that, you know, you take out when you're buying a house, you take out a big mortgage, and then you spend the next 30 or 40 years paying it off. And the analogy here with software is that sometimes you might have to do something a bit quick and dirty to get something working, to prove a concept or something like that, and then and that's sort of taking out the debt, and then you pay off the debt by making it nicer, making it cleaner, and you do that at some later date. And the reason why the mortgage analogy is nice, of course, is because when you take out that huge mortgage to buy the house, you're also being charged interest on it, so you pay back more than you took out. And with code, if you leave those unconsolidated implementations in place, or you keep using outdated external libraries and so on, or anything that you need to keep working around, if you have to keep working around on it, it's like paying interest. And so every so often, with the refactor or something like that, you go back and you pay off some of that debt, and it reduces the amount of interest that people need to pay on it. And it's usually, technical debt is usually most often found in quite large chunks, especially when teams are transitioning to Agile. Generally, if you're in an Agile project, you've been doing TDD, you've been doing refactoring all the way through, collective ownership of the code, you shouldn't see too much technical debt. A quote from this is, danger occurs, let's get it on the screen. Danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Entire engineering organisations can be brought to a standstill under the debt load of an unconsolidated implementation. And so Ward Cunningham was one of the Agile group, the Agile men, it was, wasn't it? he said this. Okay, so we should try and minimise technical debt, and the way we do that is by refactoring. So we discussed refactoring a few times. Give it a bit more of a definition now, so tests give us the security that we need when we're refactoring. We discussed a couple of times last week and already today as well. If you don't know that everything works, how can you refactor something? It's essential to know that when you're refactoring something, you're preserving the functionality, you're not breaking anything, and you don't introduce any regressions. So we must have tests before we can refactor. As I keep saying, refactoring is the process of changing how something does something, not what something is doing. And we can use tests at different levels to actually refactor at different levels. So, for example, if I'm just changing how a unit works, I'm changing how the internals of a function work, then I've got the unit test to actually ensure that that function keeps working. But what if I need to actually change the method signature of that function? I'm going to add some more functionality to it. Okay, so in that sense, what I've said up to now is that that would not be a refactor. It certainly wouldn't be a refactor at the unit level because it's changing the unit tests. But in the terms of the integration level, the entire sort of class, as it were, that we're working on, let's say we're working on a class here, the entire class might actually not change how it's working completely in relation to other classes. So we might change the signature of a couple of functions, and we might have to change some other code to cope with that, and we will have to change some of the unit tests. But the integration tests then should continue to work and should not have needed to have been changed, because the larger bits of functionality that we test in the integration test should still work. So although we're not refactoring at the unit level there, we are maybe refactoring at the integration test level. And so we've got these different levels of tests to give us protection that we're actually not breaking things at different levels. And this is why some people have these questions about how do we we're sort of refactoring because we need to change how something works, but we're not changing the whole thing, we're just changing part of the thing. And if you're saying that it's not a refactor because the tests are changing, then how do we actually do that sort of thing? Well, this is really how we get around that, in a sense. So if we hadn't changed the way something quite large in the system worked, then we might actually have to change some of the integration tests as well. But the system tests stay in place. If you remember, I gave you that example from Facebook, which is log in, post a message, log out. We can change lots of unit tests, we can change lots of integration tests, but so long as the system test still works, we've refactored within a controlled environment as far as the system is concerned. But when we're in the TDD loop and refactoring, while we're doing the red-green refactor, the unit tests must not change. So that refactor stays very much in the centre. If the acceptance tests change, then so the acceptance test is right at the outside, then that's clearly got to be driven by a high-level user story, a new piece of functionality being added, or functionality taken away, or functionality being changed in such a way. So that's not a refactor. That's a new feature or a changed feature within the product. One of the things we've put in Blackboard is a blog post called 5-factor testing, and that explains this idea in more detail. Right, is there any questions on any of that? Okay, right, so I'll pass over to Caroline.
So I've updated my slides, so hopefully you
yeah, hang on, where's my... Oh, there it is. Please leave the mouse. Found it. So has that changed recently?
Yeah, about 5 minutes ago.
Yeah, sorry, I've not given you that much time left.
It's okay. I'll cut out the boring bits. what we're going to look at in terms of estimation, so we're going to ask you to do some estimation this week. So we thought it'd be helpful to kind of go through an approach that you would use to estimation within agile processes. So I've had chats individually with several of you both today and just last week about estimation, and I think one of the things that it's important to say is that whilst we can talk about it within this kind of dry lecture theatre about, oh, this is how you should do it, oh, it all makes sense and so forth, actually doing it in reality is just massively, massively hard, and it's one of the things that it continues to remain a massive problem, particularly in software engineering. So we always have overruns from big projects, and it's particularly bad in software. So when we estimate for an agile project, we want an approach that works for stories of different sizes, so it allows us to assign different amounts of effort to different stories. It doesn't take too much time. We want to maximise work done, right? So we don't want to spend a long time on this. It provides useful information about progress, so it allows us to monitor how we're doing in terms of progress. And it can also be used to plan, right? So we want something there, we've got a metric or some way of measuring things that we can use to plan sprints and releases. We also want something that is going to be able to accommodate change and imprecision. So we're going to recognise that we're not going to get this perfect, and we want to be able to accommodate where there are some kind of potential differences, and we might need a bit of slack. So Rob has just appeared with some cards. He's going to give the cards out to everybody. So one card each, yeah? That would be excellent. Thank you very much. Right, so what we're going to ask you to do is, once you have your card, we're going to ask you to try some estimation, okay? So why have we given you a card? We've given you a card because it's very important when you're estimating that you commit, okay? So you can have in your head, it's like one of those things where when you're watching a quiz show on television and they give you the answer, when you find out what the answer is, oh yeah, I knew that, right? Okay? This happens a lot when you're looking at exam papers and stuff too. Whereas actually doing it, actually committing, makes a really big difference. And we know from the evidence that it's certainly with things like exam questions, which is why it's a good idea to do the quizzes and so on, is that if you put an answer down and you get the answer wrong, you're much more likely to then learn what the correct answer is than if you kind of you didn't bother giving an answer. You're like, oh yeah, I knew that. That sounds about right. Okay, right. So
has everyone got one?
Okay, excellent. So here is the story that we would like you to estimate in hours. Right. Let's say hours for now. So how many hours would it take you to complete this? You are allowed one decimal place if you wish. When sorting a table by column, author name should always be considered as a secondary sorting criterion if it is not the primary criterion. Okay, so that's the story that we would like you to estimate. Are there any questions about that? No. Okay, so individually, right, so we want you to do this one by yourselves. We'd like you to come up with an estimate in hours for how long it would take to complete that, and we'll give you, 30 seconds or something along those lines. Yeah?
Do you want me to
You've got a second one.
Yeah. I do.
Excuse me. What is a secondary sorting criterion?
It means that your primary one is where so if you click on author name, if you click on something, that's your primary sorting criterion. So it could be the number of publications like to load.
What is the most common thing that they usually use?
Yeah, so the second one is where so you've got, if you've got the number of publications, right, there are 3 people with 10 publications, you need to have a way of ordering that. So you order it on author name. Does that make sense? Yeah. Okay. Right, so that's more than 30 seconds, but 10 more seconds for anyone who's not written an estimate down. Is there anyone who hasn't written down an estimate yet? Okay, could you all stand up then? That's why we want commitment. Right, okay. Right, so everyone's standing. Right. Could you sit down if you went for 1 hour or less? 2 hours? 3 hours? 4 hours? There's no right answer, by the way. 5 hours? 6?
No idea.
Infinity? Okay, right, brilliant. So we have some people who went for 1 hour or less, and other people who went for 6 hours. So one of the people who went for 1 hour or less, yes?
Yeah.
What? So why did you go for 1 hour?
Because we use the data tables,
Yeah.
which are very popular, and I have seen that we can choose to the ordering style, and it has many features like that, and so probably or by putting a callback somewhere or something like this, or in the folders, we can find it.
Okay. Right, so there are a few assumptions there then. So the assumptions are you're familiar with the code base and you understand the story. You've already done some work on data tables, so you think it would be reasonably easy just to slot this in as a sample sorting criterion. Okay. And so you're familiar with the technologies and the code, so that's really useful. So somebody who went for 6 hours. Yeah, so why did you go for that?
Well, for example, like my experience may not be as high, so I may encounter problems, and those problems will lead to more hours focused on trying to solve the problems instead of having or for example, I make an error and then I have to find the bug. So it's kind of like, that's just an estimate.
Yeah, no, absolutely, it's just an estimate. So one thing that anybody who went for a longer estimate can be reassured by is that, generally speaking, people underestimate, almost always, not always, but almost always underestimate the amount of time it's going to take to complete a task. And it could be that where someone's made a longer estimate, they might be including it being done. That means things like, fully tested and everything else. Whereas it might be that an assumption that somebody could make when they're estimating and they give a lower estimate is that they're not thinking about that. So thinking away from this particular problem, this is kind of very common for a developer to have in mind that they are going to complete something quickly, because writing the kind of like basic functionality is quite straightforward, but then all of the stuff around quality assurance and getting it in front of the user and everything else just isn't factored into that time. So this is one of the common problems in software projects. Okay, but fortunately we're doing an agile project. So that means we're able to do this, we don't want to spend too much time on it. So things that you want to think about in this kind of situation are, if you're estimating as an individual, okay, we've seen just then that there are really big differences in people's estimations. So, one thing to consider is whether someone with more experience will come up with a better estimate, okay? So, this could be experience of the particular problem we're talking about. It could be experience with the code base. It could be experience in general. They could just be a more experienced software engineer. So it's kind of something that, generally speaking, you might sort of think it's easier to estimate if you're kind of more experienced in terms of software engineering, but then you have to reflect on how realistic you are about kind of your own abilities and so on. So that's another thing to think about. So another question to ask is whether it's easier to estimate for yourself or for someone else. So one might perceive it is easier to estimate for yourself, okay, because you kind of have experience yourself of trying to code and so forth. Project managers obviously spend quite a long time trying to estimate for other people, and the way they do that is, interestingly, is take the estimates that their developers give them back and times them by something, sometimes increase them by order of magnitude, I've heard as well. So at least increase them by a sort of factor of 4 or something. The other thing I think which is interesting, and I think is that statement is reflective of, is that people tend to, it's very common, so it's human nature, tend to want to appear sort of hardworking and, you know, efficient and everything else. So they will always be optimistic, nearly always be optimistic in their estimates, because they kind of don't want to say to someone, well, okay, I'm saying this is going to take an hour, and in an ideal world it would take an hour, but actually I've got, actually I've got to, I'm going to have a cup of coffee, or I need to go and get some water, or, you know, whatever. Someone might come and have a chat to me in that time, and that will slow me down. And you don't want to kind of include that, do you, in your estimate? So, right. Okay, so we're going to do a little bit more estimation, but this time we are going to estimate as a team. So it doesn't really matter how big your team is. So if you could sort of, we want a team of at least 2 people, so I guess we work together here. 2, 3 is fine. So when you kind of self-identified your teams, Rob, you did brilliantly last time giving out the cards. So if you could give one card to each team. Oh, actually, we could use the other. We could use the other side. Yeah, okay. Right. So it's okay. Rob's being efficient. So this is very good. Well done, Rob, for spotting that.
Recycling.
Yeah, exactly. So within your team, we want you to come up with one number now for the story we're going to give you. Okay. Right. Okay, so is everyone in a team with at least one other person?
So each half row is a team.
Yeah, that'll be fine. Yeah. So maybe if you guys
what's the estimate that you give?
I think we've got some of them here. Do you want to work with these two? Yeah. Well. Okay, thereabouts. Right. So we'll have a minute this time to estimate this story. So hours again, we'd like.
Oh right.
Okay, right, wherever you are now, just write down your estimation on your card, number of hours it would take to complete. Still going. Okay, we need a number in 5, 4, 3, 2, 1. Okay, right. So, who went for 1 hour? 1 hour. Okay, yep. 2 hours? 3? 4? 5? More than 5? Okay, right. Excellent. So, big variety in estimates there again. So, was there any team that made independent estimates before they claimed to a consensus? So I think everyone's sort of talking straight away. So you're looking for a consensus, yeah? So people were chatting to each other. Okay. So within Agile, there's a kind of form of estimating that we call planning poker, where it's a kind of well-established method that you go through to try to converge on a consensus. So you want a consensus by working as a team, but also working individually as well. So the way it works is that you define a story point, which is potentially an ideal hour of work. So I mentioned an ideal hour before, so maybe you're not including your coffee break in that, but you have to factor that into the sprint at some point. You ask the customer any questions about the story they're estimating. So I had a couple of questions before, so this is very sensible. Then, by yourselves, you each write an estimate on a card. And then when everyone's finished, you turn your cards over. And the key thing is here, you have to justify your estimates. So you don't start discussing straight away, but you justify your estimates to the rest of the team. And this is a way of exposing people's kind of concerns or thoughts about the actual task, but without having a situation where you're in a consensus. Because when you kind of start talking straight away, it is often the case, not always, that certain people, you know, oh, they have more experience, or there's stronger voices in the team or whatever, and they'll just say, oh, I think it's this, and everyone will go, yeah, that's right. Whereas if you have to have written something down yourself, and then you have to justify it, you may come up with something that people say, oh, actually, yeah, that's a really good point. We haven't thought about that. So, and you then go through the process again. So the goal is to converge on a single estimate, but disagreement is good, right? So this is a really positive thing because it prompts people to think about different approaches. So obviously, again, things like the kind of approach that someone has in mind when they're estimating is going to make a difference. After discussion, estimate again. So you go through the process again. But being reasonable is more important than precision. So what we don't want is people to be kind of arguing over the last 10 minutes for most of the day. You kind of just want to kind of get it done after 2 or 3 rounds. So how do we use story points? Well, we want to count the points that we're completing in a sprint. So this is one way of doing it. And then you can use that to work out your velocity. So how many story points you're completing in a sprint is your team velocity. So you might have your first few sprints trying to understand your velocity, and then you use that to plan future sprints. You need to consider changes, okay, to things like the team, the environment, any changes to the practices you're using, and of course any changes to the estimation process. So if you redefine how you define a point. When you're planning a sprint, you want to discuss the stories with the customer. Okay, this is very important, as we know, so you can work out that you understand exactly what you're doing, work out the details. Split the story into constituent tasks, and then each developer takes responsibility for one task. They then go back and individually estimate the tasks they've accepted to make sure they're not overcommitted. So again, this is really important at the start. If someone's sat there panicking, going, oh, actually, I'm probably not going to be able to get all this done, go and have a chat with the team about it. Because ultimately, completion is a whole team responsibility. So if the software isn't ready, no one outside of the team is going to worry about whose fault it was that it isn't ready. Okay? So we want the team to be kind of working together and helping each other. So, one last thing that I wanted to say about story points and why they're useful, because there'll be people who presumably are sitting there quite reasonably thinking, well, if a story point is like an hour, why not just call it hours? Okay, this would make more sense, it would be more meaningful to people, so why are we calling them points? So one way that points are useful is for dealing with different levels of experience within a team, okay? So if you've got somebody who's a very experienced software engineer and they've been in the team for like 5 years, and you've got a trainee who's just joined and they have no idea kind of what's going on and they haven't used the systems before and all this kind of stuff, then it means that the amount of, if you're defining a story point as an average amount of work that you can do in an hour, so you've kind of got a development average, an average of the team, then it makes sense for a more experienced developer to take on more story points than a less experienced one. So this is one of the ways of dealing with this within agile planning. So you need to make sure that you kind of are completing a certain number of points per sprint, and you know what it is, and that's kind of based on a rough average. But actually, the way you allocate work can take that into account. So you'll note that on this sprint backlog here, for example, we've got Robert and Alan each taking on 10 points because that's the amount of work they'll be able to do in this sprint. But Caroline, who's considerably more experienced and just, you know, demon coder, is taking on 20 points because she's going to be able to get a lot more done in that sprint. So this is the kind of approach that you can use when you're planning within your own team. So if you're all an equal kind of level of experience, then you can all have you can all allocate the same number of points. You're allocated the same number of points. Whereas if you are perhaps differing in your levels of experience, you can take that into account. So I showed you a burn down chart last week. Here's an example of a burn up chart. So I'm sure you've been looking these up online. So this one is looking at the sort of the total here that we are aiming towards. And this is, the red line is the number of points that people have actually completed in each sprint. So you're able to sort of see the average. It's a nice straight line, so they're doing very well on this, very good at estimating. So obviously in the what we also asked you to do, which isn't on here, is have maybe different lines or have some way of monitoring your planned versus actual completed amount of work in terms of whether you're getting your point calculations right. In the lab this week, and there'll be information about this in the lab manual, we want you to estimate of the stories you're given how many you will complete, okay? And you need to email me as a team by the end of today, possibly. I might change that to tomorrow. Anyway, we'll see. End of today. That'll be all right. Yeah, we could do it. I'll check that in the lab manual when the deadline is. We don't normally have the course on Fridays, so so you need to email me and tell me how many stories you're going to be completing and which stories they're going to be. So some teams will do all of them, and other teams will not do all of them. Okay, so you want to think about it because you've got to be able to justify to the TA and to me why you've made your decision. So it's no good going, oh yeah, just do one story this week because I've got loads of other coursework or whatever. It's more to do with, can you demonstrate from the way you've been monitoring your progress that you can justify your estimates? Yes?
The vertical axis shows the number of hours.
Yeah, so this is number of points, I guess, here.
In hours?
I don't know. I'm not sure how they've... Yeah, so I would say this is points. It could be hours. I'm not sure. So it's not specified, is it? So, yeah, so whatever a point means, yeah.
Excuse me.
Yeah.
Can I monitor the estimation of each member of the group and how much did get from him in each week? So whenever we do an estimation later on,
Yeah.
I can use the previous data for each member.
Yeah, it's fine to do it on that level if you want to. So in terms of what we're asking you to do in the sprint review, it's really sort of at a team level. And the TAs might ask you questions about how you're kind of making decisions and how you're monitoring things. So we don't require it for each individual, but you could do that if you thought it was helpful within your team. That would be fine. Okay, so if there are no other questions, we will have just a 5-minute break now. To introduce our guest lecturers from ThoughtWorks, we're going to be here to tell us about continuous delivery.
Hi everyone. Hello everybody. Thank you very much for having us today. We're very happy to be here. Our presentation is going to be about continuous delivery and some ways of enabling it in software development projects. If you have any questions that you'd like us to answer at the end of this presentation, please get onto Slido, and it's the code F806. Please ask questions as we go, in case you forget them. And like if you forget the code for Slido, it will always be on the bottom right corner of the slide. Yeah. Cool. So the agenda for today is going to be a bit about who we are. We're going to have a hypothetical client scenario, and then we're going to dive into the benefits of continuous delivery, how to enable it, and then at the end we're going to have a Q&A session. So starting with who we are, my name is Andre. I'm a software developer consultant at ThoughtWorks, and this is my colleague and friend Dragos, also a software developer consultant. We work for ThoughtWorks, a global consultancy which has over 7,000 employees, and we're located in 14 countries, in 43 offices, and we have more than 25 years experience. If you're interested about the latest news in terms of technologies, we have a publication called the Technology Radar, which was released, the new volume was released 2 days ago. So if you're interested about this, just get on the website and find out more. We're also hiring for the 2020 Graduate Software Developers Intake. So if you're interested in joining us, please speak with us after the presentation, or just get onto the website for more information. Our mission is to create extraordinary impact on the world through our culture and technology excellence. We're going to start with the client scenario, and I'll hand over to Dragoš for this.
Thanks, Andrei. So, this is quite common. We start engaging with clients, and in this particular case, we are engaging with a client in the banking sector. And what's happening there is they're under pressure to deliver new products and new features a lot quicker and a lot faster because they're feeling the pressure from the startup banks like Monzo and Revolut and so on. Their current release schedule is twice a year with big staggered releases. And what happens and what they notice is they discover bugs in production that were not picked up in testing. They ask us to do agile, and they have heard of this thing called continuous delivery. But before I move forward, I just want to make it very clear. Agile and continuous delivery are not the solution to company problems. They are ways of enabling software and getting software in the hands of customers. They will not solve problems with organizations. These require organizational and cultural shifts. Also, we tell them, don't do agile, be agile. So with that in mind, let's look at what is continuous delivery now, and then later on in the presentation we'll talk about agile and what does that tell people. So in kind of loose definition, continuous delivery is the ability to get changes, either new changes, features, or bug fixes, into the hands of your customer so that they can see it and to get them safely and quickly, also in a sustainable way. So let's talk a bit about why. Why do you want to do this? And then Andrei will talk a bit later about how you get there. Let's understand the benefits of continuous delivery before we try and do it. So one of the important things, it enables frequent releases. You don't wait a long time to get your changes in the hand of the customer. You do it very quickly. And because you do it so often, it obviously will be painful in the beginning, especially if you have not done it that before. But as you do it more and more often, they become less painful because you optimize that process and you do your best to make it as easy as possible. Very often we see that people avoid doing that, or they try to do it out of hours or during the weekend so that they don't have any downtime with their customers. You get feedback early from the users, and you understand if you're actually building something of value. You don't wait a long time to validate your assumptions. And finally, it improves customer satisfaction because instead of waiting a long time and then delivering a huge amount of features that will probably confuse your users because there's so many things changed, and probably one or them will actually be used, you get them in their hands again really, really early. It enables teams to work and think and reason about in smaller batches because you do small changes and you make sure they are of value, and then you deliver that. Again, it allows your product to get to market a lot faster. You start with something that's smaller and of value, and then you continue to iterate on that. And it also increases software quality and stability. And finally, it's about failure management and being better at that. Instead of avoiding and trying to deliver the best product ever, and when it's ready, you prepare for it and prepare to manage that failure. Defects are caught a lot early in testing because the changes are a lot smaller instead of being a huge batch. And it enables you to do easy rollback or fix forward because you can identify a lot quicker what has gone wrong. So if we go back to the client scenario that I talked about, imagine this is them. They are now preparing to do the second release of this year. They have a lot of changes staggered to go into production. And obviously what that means is they probably are already preparing for next year's release. So the difference there is probably 6 months. So they are preparing for the release of next year. And in this scenario, we have changes from a couple of different teams. And the red blocks down there, they're bugs that have not been discovered yet in testing. Now imagine, obviously this could be from different teams across a couple of services or software systems. Imagine if these were related. So they're not just isolated to the individual teams, but when you connect them, you actually you end up with a flow that's broken. So So you don't end up with just one defect or one bug. You end up with a super bug, which is going to be a lot harder to fix and identify. And then let's say you get this to production. What happens if you discover this in production? Do you roll back 6 months of changes and then you wait another 6 months to fix? Or do you leave it in production for 6 months and then hope that in the next release you will fix it? So with continuous delivery, instead of thinking of a huge amount of change in blocks, you think of them as maybe daily, release daily. And sure, let's just assume that these bugs are still there and have still not been discovered, just for the sake of the argument. So we're now on the 336th day of this year. We're going to prepare for this release, and we're going to release a bug. But because we're releasing this, it's probably a matter of time of 1 or 2 days to find out actually there is something wrong, and we can just roll back 2 or 3 days. We work on fixing that, and then next week we can release the fix, and we can continue. Okay. So in terms of deployment frequency, Amazon releases about 11.7 seconds. Netflix, more than 1,000 times a day. Etsy, 50 times deployments per day. And if you're like me and Andre, when we saw these numbers, you're like, what? Like, ever since we started, Amazon has probably done like 50 releases. Okay, so how do you get there? How do you get to deliver something small but of value, which is really important? You start with this build, measure, learn loop. You start with the hypothesis of what you think would be valuable to your user. You build a minimum valuable product. And you may have heard of this thing called a minimum viable product. The focus here is on value, not on what's viable. You get that into the hands of a customer, you seek feedback, and then you learn from the feedback. And you continue that. You repeat that, and on and on and on. So in this particular case, with value, let's say you have to get moving. And then if you're aiming to build a scooter, well, you'll have to start with wheels, and then some of the metal and carcass and everything. And you will deliver value at the very end. But if you get to get moving now, well, a skateboard might do, or a little bicycle. You know, you will get moving now, and then you can continue to iterate on how you get there as you go. And then you deliver value at every stage. You don't wait up until the end. And then in terms of failure management, you get to identify issues a lot quicker and restore your service a lot quicker. So you don't end up with finding out what's wrong with your product from other people on social media or from other services, competing services. There's a really good video that emphasizes how you can do that and how you can manage a failure if you do it in smaller batches when you know your system really well, which is a video by the Canadian Army who disassembles their Jeep. But to make, because of time, we're not going to watch that, but I recommend you have a look on YouTube. It's called Canadian Army Disassembling a Jeep or something. It's really obvious. But the focus here is, obviously you can go with a really good quality product, which in our case would be a BMW. They're known for quality, but obviously they're a lot more expensive, so you have a big upfront investment into your product. They will have a lower failure rate. But when it fails, when something's broken with that BMW, well, you better be prepared to pay some money to repair it, because it's of a certain quality, and you want to make sure that it comes from the BMW repair center. In this case, risk is avoided. You try to avoid risk. However, in software, we try to focus on minimizing the average time to restore your service, not to minimize. To maximize the time between your failures. So you have a small upfront investment of time or money. You will have a higher rate of failure, and you have to accept that because you want to be prepared for that failure. It will happen. Data center goes down, internet goes down, DDoS attack, doesn't matter. Something will go wrong, and you have to be prepared for that. But when it fails, it's easy and cheap to fix, not expensive to your business or to your people. And in this case, risk is managed and accounted for. And there was a research done. I'd recommend this book. It's called Accelerate Building and Scaling High-Performance Technology Organizations. And they measured these 4 key metrics: the deployment frequency, the lead time to get changes from development into production, the time to restore a service when it goes down, but also how often your software breaks. And it's really interesting. I'm just going to tell you how the elite performers are doing out there. So in terms of deployment frequency, they're doing it on demand, whenever they want to do that, or multiple times a day. The time it takes for them to get from development into production is less than 1 day. If something goes wrong, if the system goes down, they're able to put it back up in less than an hour. And the frequency to which their software breaks is under 15%. So the probability for the thing to break when you develop it is under 50%. And that's because, going back to Agile, and what we want to do is provide value. And the first principle of Agile says, our highest priority is satisfy the customer. And do that through early and continuous delivery of valuable software. Not just software, valuable software. And to tell you a bit more about how you do that, I'll pass it back to Andre.
Thank you. So it's in the why, and now we're going to focus on how do we implement continuous delivery in our software development projects. And we've got something that we call the 3 pillars of continuous delivery. So we've got the patterns and practices that we can implement when writing our code. We've got ways of getting fast and automated feedback. And there's also like the people side of it, where we got collaboration between people in the team. We're going to start with looking at the patterns and practices, and the first thing we're going to focus on is clean coding. So when we're writing our code, we'd like it to be readable, and whenever we hand over our project, for example, if someone else looks at the code, we want it to be readable. We want them to understand what we have done in the code. So we've got some key principles that we need to follow when doing clean coding, which are KISS, keep it simple, stupid; dry, do not repeat yourself; YAGNI, you ain't gonna need it. This is when you're writing methods and you just want to do the necessary when you're writing that method. You don't want to do something else if you're not using the functionality. Favor readable code over succinct code, composition over inheritance, and tested code. So in order to achieve this clean coding, we need to eliminate code smells. So examples of smells here are the bloaters, which are long methods or classes with long parameter lists; object-oriented abusers like complex switch statements or temporary fields; change preventers, dispensables like tons of comments, duplicate code, lazy classes; and couplers like feature envy, middlemen, message chains. So in terms of the variable and the methods naming, we want to make sure that we're not naming our variable X or ABC. This is because we want the variable or the method to have a pronounceable and searchable name whenever we're looking for something in the code. We want to reveal our intention, and we'd like to use the domain and business name and context. So we want to make sure that if we're implementing a method to add 2 numbers, we name it add, not X. In terms of functions as well, we need to keep them small with low number of parameters, free of side effects, 0 or limited duplication, and also the function should handle the errors and avoid lots of comments. The reason why we shouldn't have lots of comments in the code is that the code should be self-explanatory, so we shouldn't just have loads of comments between lines of code. And if you'd like to learn more, there's this book, Clean Code, Handbook of Agile Software Craftsmanship by Robert Martin, if you're interested to learn more about it. So moving forward to test-driven development. Can you raise your hand if you heard about TDD, test-driven development? Cool. It's really good.
Yeah.
Good.
That's very good. When I started, I had no idea about test-driven development, and I found it really hard. But then, like, once you keep going, you just get used to it. So, for example, we'd like to implement a method which will calculate the square of a number. So all we need to do, we're writing a test, which in this case should return 0 when 0 is passed. So if we're running this test, it obviously fails. We haven't implemented anything. So the minimum amount of steps we need to do to make this test pass is by just returning 0. If we're running the test, this obviously passes, so we move forward. The next test should return 1 when 1 is passed, which is obviously failing. This is not what our method is doing. So the change we need to do is to return the actual number, and then both our tests are passing. So the next one is should return 4 when 2 is passed, and this is failing. So at this point, we can actually implement the logic of the method, which is returning number times number, and we want to make sure that all our tests are passing, not only the last one. And we can also do some refactoring, so we can use one of the libraries and just return math power of number, and we're all good to go. Version control. So I assume everyone has heard of Git and all the popular tools like GitHub and GitLab, Bitbucket. Version control is the system that records the changes to our code, which we push to one source repository. So we can always recall some specific versions in case we want to roll back, or in case we want to see what was the change between our current version and a specific one from the past. So when going on a project and you're trying to implement a new feature, a way of doing it is by using feature branches. So from the master, you can just pull a branch, and then you start implementing the logic, and then at the end of it, you just merge it back to master. The risks of having feature branches is having a large amount of changes that have been applied, which leads to high risk of merge conflicts. And when we're trying to merge from a branch to master with a large number of changes, we get to something which we call the merge hell, where you have to go back and actually merge them separately. Also, this is a high risk of breaking changes due to other changes. So a way of avoiding that is by using trunk-based development, which is a source control branching model where we work on a single branch, which is usually the master, and we call it trunk. And this will resist any pressure to create other long-lived branches, which, if we're using feature branches, we can just leave them there and forget about them. And this way we avoid that merge hell, we do not break the build, and we live happily ever after. So the principles of trunk-based development are having small and frequent commits, tested code, and commits checked in frequently. The reason why we want this is because if we're having small and frequent commits, if something breaks, we know exactly what we've done, and we can always go back and change it really fast. If we have a large amount of changes that are just pushed to master, then we'll have to investigate and it will take longer. And this way we also avoid the painful merge conflicts, and we reduce the risk of breaking changes. So let's have an example. We have our remote master branch with commits X and Y, which have the test passing. It's all green. And meanwhile, Dragos has his own version of the master branch on his local machine with commit X. So because they're out of sync now, he needs to do a pull. So he updates his local branch to be in sync with the remote one. And at this point, he starts implementing a feature, and because he's an expert in TDD at this point, he starts with a test which fails. He starts implementing the feature, and then he makes the test pass, and then he's ready to push. He's got commit Z ready. Meanwhile, I was also starting working on a feature, so I have my local version of master branch with commits X and Y. I start implementing the feature. I start writing TDD as well, because I'm also an expert in this now that I've learned it. And Dragos, being ready to push, has to pull first, so he makes sure that no one else has pushed on the branch. And then, if there are no changes, he can push on the remote master branch. So now we've got commit Z, which has all the tests passing. During this time, I also finished the implementation of the feature. I've got the green tests. I'm doing some refactoring. I want to improve something in my code. And then I'm ready to push as well with commit W. So I need to do a pull to see if anyone else has pushed on the branch. And obviously Dragos has. So what happens here, his changes are going to be applied on my branch. So the commit Z is going to be rebased, and then my changes are going to be put on top of his changes. I'm doing some refactor because I can see there's something I can improve. The tests are green, so I'm pulling again just to make sure that after that there are no other changes on the master branch, and I'm ready to push. So at this point everything is green and we're ready to go. So we talked about the patterns and practices. So let's see some ways of getting fast and automated feedback. So we're going to start with continuous delivery. Integration, sorry. Which is the process of automating the build and testing of code every time someone commits the changes to the version control. And this encourages the developers to share their code by merging their changes into shared version control repository frequently. So this way we make sure that we get fast feedback in regards to our changes, and it enables the easy rollbacks that we talked about when there's change that breaks the build. Also, this is an enabler of deploying to production and other environments at any time, which I'm going to demonstrate a bit later. So these are some tools for continuous integration. So the most popular are like GoCD, Travis CI, Circle CI, and Jenkins. This is an example of the GoCD pipeline. So we've got stages like the build stage over here, or we've got some smoke tests. We've got the regression tests, which are red and is not good. So moving forward to pipelines, this is an example of how a pipeline looks like. So these blocks are called environments. So in our scenario, we've got the dev environment, the QA for the tester to do some more work on it, and then staging, which in our case is something where we'd like to demonstrate to the business what we've done, and then we've got production. So what happens? We have our source Git repository, which is GitLab here. When there are some changes, we can configure the pipeline to trigger automatically to poll GitLab for changes, and then it runs the automate build, automate unit and integration tests at this point, and then it can automatically deploy to QA environment. What we've got here are some manual steps, which we can also have on the pipeline. Reason being, the tester might not want to push a specific version to the business because he wants to do some more work, or maybe to production. Maybe we don't want every version to be in production. We want to get like the green lights from the business, for example. Or we can have some breaking tests in one of the environments. So in our case, we got the journey tests, which are red in our staging environment. So at this point, we can either roll back to a previous version, and then we make sure that the production is still green. Or what we can do, we can just push a fix, and this way we make sure that everything is all right, and we push everything to production. Testing pyramid and quadrants. So we've got this, which we call the testing pyramid, which has the base of unit tests, and these are the fastest and the cheapest tests that we can have in our code. Unit tests are usually implemented to test all our methods, and we should have as many unit tests as possible. And moving up the pyramid, we've got integration tests, which are also testing the integration of our components, or they're using real data, because in our unit tests we can use our mocks. And on top of the pyramid, we got UI or functional tests. We should not be as many as the unit test or the integration test. The reason being, they take really long to run, and also they're very expensive. We can also put the tests in 4 categories. So we have, starting with the bottom left, the first quadrant, with our unit tests, component tests, and integration tests, which are fully automated and are technology facing. And then moving to the second quadrant, we've got automated and manual tests, like the functional tests, simulations, or prototypes. Third quadrant has some manual tests, which are usually done by the QA, for example, exploratory testing or usability scenarios. And also, like fourth quadrant are some complementary tests, which will help us, for example, all the ELITI tests, monitorability, auditability, and also the performance and load testing or security testing.
Can I, sorry,
Yeah.
I have to say traceability, by the way, sorry about that.
Thank you. Putting them in perspective, like all the quadrants on the pyramid, on the bottom of the pyramid we'll have the first quadrant of tests, in the middle the second with the functional test examples, and on top of that we've got the exploratory, the manual tests basically, which are the most expensive and the slowest. And we put the fourth quadrant in here because they're actually complementary tests. They can be either automated or manual, depending on the technology we're using. They're complementary to our tests. So for the last bit, collaboration between people, I'm going to hand over to Dragos again.
So I'll stop here just for 1 second to remind people, please ask the questions on Slido and use this code. I've seen 5 so far, 1 which is good feedback, so 4. Mainly because what you, and also please vote on other people's questions. So the one you want to hear most, because we have some swag at the end. We have t-shirts, socks, and some Sharpies to give out. The top 2 questions will get one of these, and then if we have time, which I hope we do, we'll play a game at the end, and the top 3 winners of that game will also get some swag. So we have 5 prizes to give out. So, slide. Right, so now that we've collaborated a bit, by that I mean I told you what to do, let's move on to collaboration. And I think this is coming back to what I said. We talked about how to, why to do continuous delivery and how to do it. But let's go back to Agile and why it's important to look back and think of the values of that. And for me, actually, these are the most important because the tools are the tools, and you can implement them. But at the end of the day, you'll have to work with people, and the people are more important than the tools you use. So I said at the beginning, don't do Agile. Be Agile. And Agile is about change, accepting change, and putting people first, and being ready to get and act on your feedback. So the first tip is work on creating great teams. So you're working probably in teams. I'm sure you have a lot of projects that you have to work in teams. But you'll go out in the industry, and then you'll have to work with other people. You won't be coding by yourself, or just in a one-member team. So what we try and tell our customer, our banking customer, is try to nurture safe environments for people to welcome making mistakes, because they will happen, and that's just how it is. Like, you can't be perfect all the time, you can't write code that works all the time, and so on. And again, the most important part is make those mistakes and then learn from them, and share that with your team so that you all learn together. And on the flip side, try to identify and stop the blame culture. If things go wrong, don't say, hey, it's you that broke this. Let's work together, understand what's wrong, and learn from it. And also stop a hero culture where the knowledge is only in one people's head, or a bulk area of the domain is only on specific people. Because it creates single point of failures, but not in your code, but on people. And then you end up with blockers. Because if they fall sick, if they're fired, or if they leave the company, then they will take that away with them. Focus on growth, both individual, but also collective growth, and knowledge sharing. So get together and learn together. And also, something that's really important is giving and receiving feedback. Learn to ask for feedback. You don't have to accept it all, but you have to be able to listen. And then try to improve on that. And then, again, focus on people, your team, and the collaboration part, because that's the more important. At the end of the day, you'll have to work with these people for a long time. The tools and the language and the frameworks, those will change, because they have to change to adapt to the times. So allow people to work closely together and share this knowledge. We will share, by the way, we will share this, so don't worry. And build context and a shared understanding of what you need to build, because that's how you deliver value. If you understand what you're building and why you're building and why it's valuable to your customer, then you'll do a better job and you'll be more involved in the quality of that product. And then work as close as possible to your customer or to your user. This goes back to seeking and receiving feedback and validating your assumptions. Because you may think you build the right thing, but you won't know until you get it in the hands of customer. And they may have thought of something different than you did. And again, embrace change. Seek feedback and embrace that feedback and change. Don't get stuck into set processes. Whether you do in software development, whether you do Lean, Kanban, Scrum, or any other framework, or Waterfall, hopefully not. But don't get stuck into that, just because you've always done it like that. And you'll hear that probably a lot, just because we've done it like this forever. And what we advocate for is this idea of a DevOps culture. What does that mean? It means increasing collaboration between you as the people who build the software and those who will support or deploy your software. And coming together and understand that you're not just building the product, you will also have to improve it and support it. Once it goes live, this will be a cycle. It won't be just, oh, I'm just doing this bit and then now it's on your side. Bring those people together and understand both your pain points but their pain points as well, so you can actually collectively make things better. This encourages a shared responsibility of whatever you're building, either an app, website, software, a system, whatnot. Because now you care about the whole lifecycle of the product, not just when you just develop it or when you pass it on to your testers, but also when you're going in production and users will say something's broken, and then you want to know about that. And you want to be at the forefront of that, not the last one to find out. On the team level, it means bringing all the roles working together. So what we think is best is if BAs, devs and QAs work together in the very beginning, even before the requirements are set. It's not just the BA's job to have an input on that. Yes, they will have more knowledge, but that's the whole point. Work together with them to understand the product even before you build it. And then when you develop something, pair with QAs so that you build quality and testing and think of testing scenario right when you do it, not afterwards, so that you can have something back from the QA saying, hey, this is not working. Do it at the time you develop it. You're saving time. And after that, QAs should pair with devs to learn maybe how to program, how to create scripts and automate the scripts to make their lives easier and allow for more exploratory testing instead of repetitive tasks. It's as much about building the right thing, but also about building the thing right. So let's move on to practices and ceremonies. And initially I called this slide agile practices, but it's not about agile. It's about people. So what you find out if you work in software is this idea of stand-up, a daily, regular update on what's your progress and what you have been doing. People will say maybe how much progress they've done or not done, what are the blockers, maybe ask for help, ask for opinions and see what other people think. Huddles is when the teams get together to ask for another opinion, a different perspective, maybe take a collective decision. It can be both business but also technical, architectural decision of the software. You learn together and you share knowledge. Retrospectives are very popular despite what flavor of agile you're doing, because it allows teams to get together regularly and discuss issues and what's not going well, but also to celebrate what is going on and appreciate other people. It allows people to take actions and solve conflicts. And finally, we talked about value and software and getting into your customer hands really early. And the way to do that is to showcase, where you bring the changes you've done, maybe even bug fixes, because that's value, right? You're decreasing the frustration of your user, into a showcase. And the best thing to do there is to try and validate your assumptions. And maybe they were wrong, and that's totally fine, because you accept and embrace change, and then you go back and improve the software. And then when it gets to your actual users, or the large scale of users, you will be better. You will be what they wanted. Next, pair programming. I kind of hinted at this before when I said building the DevOps culture and people pairing together. Has anyone heard of this before? Okay, has anyone done this before? Okay, woo, good, right. So you'll know this. Usually, classic is people get onto the laptops and they start coding, and then I don't know, you end up with hours and hours of coding, and you end up in a rabbit hole. Now, what we suggest is actually don't do it by yourself, because when you do it to somebody else, you can get feedback a lot earlier on. you can validate your assumptions, your own misconceptions, or you can clarify questions, you can get a different perspective. And it's not just between devs. Again, it can be with a QA. You can learn from their experience and what they want tested, and they can learn from you on how can they, what has been developed and what has not been developed. It's as much about creating and building the quality right into the product as understanding the compromises you have to make. Again, it builds a shared understanding of what's been done, what's been coded, and allows knowledge transfer. More importantly, it will reduce knowledge silos. Because if you code together with another person, maybe tomorrow you'll fall sick. And that's inevitable. You don't want to be a blocker for your team. You want the work to continue. And if you do it with another person, they will be able to do that. Because previously, the day before, you knew what compromises you had to make. You knew what code you wrote. And also, by doing this, you eliminate code reviews. It's something we see very often. People code and then they push their branch or remote branch, either with feature branch or trunk-based development, and then somebody else comes in. And there's a lot to take in, to go through a lot of code change and understanding why you've done that. By doing pair programming, you're doing that when you're developing, not after. And then you don't necessarily have to go back and change stuff. And with that comes dev swapping, because staying and sticking with somebody for a long time can be challenging and tiring. So you want to maybe get a different perspective. So you swap the person you're pairing with. Again, that continues the knowledge transfer and continues the shared understanding. Right, so far we focused on the first bit, continuous delivery and being able to do it, because Andre mentioned, you can have a manual step. It's not about getting into production as fast as possible. It's being able to do that if the business wants you to do that. So let's focus on the second part, doing it safely and quickly, and most importantly, in a sustainable way. So, how quickly? Like, who decides if you release today, now, tomorrow, next week? Well, continuous delivery allows you to be ready to deploy any passing builds into production. Just because the code is deployed doesn't mean it's released or available to your users, or that path is available or reachable in your flow. Code, for instance, code for every next feature that Facebook is building or about to release is already in the website and in your phone. It's just not available to you yet. And the way you do that is using feature toggles. Has anyone heard of feature toggles? Awesome. The idea is quite simple. In code, you have a flag, a boolean, which can be true or false. If it's true, you show the newest feature. If it's false, you just default to whatever you had before. It enables you to do two things. Either prepare for a big launch, hide things that are not ready yet, or just wait for the business to say, yes, we're happy to continue. And that was it, the 3 pillars of continuous delivery. Right, we'll move back. We'll move to questions. And hopefully you did.
Yes, we've got a lot
awesome.
of questions.
Okay. How do you do UI tests? Is this fully automated, or does it require someone actually doing user journey manually? So it's a combination of both. You can do what we suggest, because they're the most expensive and they take the longest time to run, is try to do UI tests or automated UI tests for journeys to make sure that the main journeys are not broken. So let's say if you are in the banking sector, you want to make sure the user can log in, check their balance, maybe make a payment. But you have other journey around signing up for new products, maybe a mortgage and so on. So focus on the journeys that your user will most likely to go, so you ensure that doesn't break. And then, yes, things might break. But that's what exploratory testings are for. So you want to push those down the pyramid. The base should be automated because they're repetitive, whereas exploratory testing are the ones that are more expensive, and this can be picked up by QAs.
So as you said, if you've got some edge cases that you want to check, it's better to do these like manual, like through exploratory testing, and then just test the main journeys.
Do you split large applications into isolated chunks which are individually deployable? Has this helped with continuous delivery?
Should I take this?
Yes.
Okay. Yes, we do split large applications into chunks. Have you heard of like microservices? No?
No.
Okay. So when we've got a large application, what we do, we just split it in what we call microservices, which have like their own like role. So they got like single responsibility, and then we've got a pipeline for each. So when we deploy like the microservice. We're not deploying the whole thing.
It's best to separate. Maybe you've heard of monolith. Okay. But it's best to separate them by the business domain boundaries that you have. So in the scenario that we gave you, maybe you have a payment service, maybe you have an insurance service, and they both kind of deal with that part of the journey flow. You may have asset insurance, mortgage, and so on. Who's anonymous? Second anonymous. And who's valid? Cool. We'll see you at the end. I think we have time for one more question. Besides, yes, we share. What's this? No. Is it easy to deploy from CI pipeline to cloud-based infrastructure service like?
I think that's, yeah, I can answer that.
Yes, please.
So yeah, I worked on an infrastructure project, and it's easy to deploy from a CI pipeline. It's just taking long, and you can't really do tests with infrastructure. So, for example, you've got Terraform, which is an automated way of just spinning up infrastructure and then bring it down all the times. And you've got, you can use Python as well, which will help you with the automation of the pipeline. It's pretty easy to deploy. There are other challenges around it because it's not like normal app development. But yeah, like you can use the CI pipeline there.
Is there any other question?
Yeah, we've got 12 questions.
Oh, cool. Okay. So we're happy to answer these at the end if you want to stay a bit longer. Mainly because we want to do a game with you. You can do both on your laptop or on your phone. You don't have to download any app, you just go on the website. It's called Kahoot. Yeah, let's do play.
Did you turn off?
Yeah, just have a look at game options just to make sure. We tried this last night and it was a disaster. Just kidding. Just kidding. We tested it early, so we get fast feedback. Is that okay?
Yeah.
Okay.
Are we doing nickname generator?
No. Okay. So we'll toggle off the nickname generator. So please put friendly names, nothing inappropriate. So go onto the website Kahoot. Ooh. Can we stop this music, please?
Yes, I can.
Oh, here. There you go. Is this our game? Okay. We have Bali. So just to give you a short intro, so you'll see the question on this screen and you'll answer on your screen. You'll have...
There's a different color per answer, so
yes.
If you want to answer, yeah.
Also, don't look at other people because they're random for everybody. Just think...
you made one?
No.
As in, the order is not...
And you need to be as quick as possible as well.
Yeah, the quicker you are, the more points you get. Obviously, if the answer is correct. If the answer is wrong, it's just wrong. The first question, star. Joker. Okay. So the first question is a test question. You'll get 0 points just to get you used to how it works, and then we'll continue with the following questions. There are 10 questions, I think. And at the end, we'll see the top 3, which will get the other 3 gifts. And if it's Vali or anonymous in the back, you will not get 2. I'm sorry. We'll just pick the next 2, I guess. But feel free to enjoy it.
Cool.
Are we waiting for somebody?
Is everyone ready?
If you're not ready, we can wait. So Kahoot.it and enter that number. You can do it both from your from your phone and a website. Right. Hands up who's not ready. Who's not ready?
Yeah, it's...
okay.
Yeah.
So hand up if you are not ready. If you're not in this.
Do you need any help there? Like, no? Okay.
23 players earlier.
Yeah. Yeah. Ready? Cool. I'll start
Okay.
it.
So, I'll do the first one, okay? What's the name of the software consultancy we are representing today? It's okay, I think this is fun. Alright, everyone has to answer. We're waiting for you.
You pick the colours.
Alright, yes, it's ThoughtWorks. Not ThoughtWorks.
ThinkWorks.
ThinkWorks, that's our favorite.
Okay, so it's 0 points for this one. Are you ready for the next question?
Ready?
Cool.
Anyone not ready? Well, too late.
Which is not an advantage of DevOps?
I mentioned you can select multiple options.
Cool.
Okay.
So we've got star on the first place. Cool.
Alright,
Ready?
next question. What is the fastest and cheapest type of tests? Ooh, very good. Alright, two more. The fastest and cheapest type of test. Alright, cool, yes.
Cool.
So the fastest and cheapest, not the most expensive ones. Alright, ooh, so
Cool.
close, so close. 6
Yeah.
points. Difference between first and second.
Next question. What is the process of running automated tests as part of the delivery pipeline?
Not as quick this time. Yes, it's continuous
well done.
integration.
So we still got like
So MMU is on a streak right now.
with
4 correct answers.
Come on, I mean.
Next question is yours.
So what does D stand for? This is exciting. We did not choose the music, by the way. Yes,
Well
wow.
done.
Really good. Test-driven development.
Cool. Next question.
4 players hit a streak now.
Is true or false? A retrospective is a regular team meeting to reflect, discuss issues, take actions, and solve conflicts.
Is it? Yes,
Ooh,
yes it is.
well done.
That's why you do a retrospective, to look back.
4 players just hit answer streak 4.
Awesome.
Well done.
Star is on top. Star. It's like my pinna. Okay, what is the correct order of tasks when doing test-driven development? The correct order of writing tests when doing TDD. Yes.
Well
You
done.
write a test, you fix the test, and then improve your solution. Okay.
Oh, MMU is now first.
And Dimitri is coming on top. Second. But
True or false? Deployment is the process of releasing software.
should this. Okay. Yes,
Cool.
it's false.
So-
Deploying doesn't mean it's
Release,
released.
yeah.
Just because it's there doesn't mean it's reachable to your users. Okay.
Cool.
Ooh,
Now that
Dimitris.
Dimitris.
Awesome.
Sorry.
Last one to join, first one on the top.
Next one. Which of the following are collaboration principles?
Yes, 3 correct answers. All right.
Cool. Dimitri's first, MME is second, Rob third. So we got 2 more questions.
Which is not considered a code smell? Good luck. Yes. So I guess let's just clear this one up, because this has names and variables. First of all, it has a name that you don't know what it does. Second, it doesn't do anything actually, because it doesn't
Return anything.
You just do stuff with it. Then, if you have functions in Go parameters list, you have to question why do you have to send so many parameters. And finally, if your code has a ton of comments,